Okay, pre-calc guys, here's a really big idea. It's going to drive you crazy for a while, but I think if we take our time and we go through this video and then you look at what we have to do to talk about continuity and end behavior and limits, which is our next section, I think you're going to understand it and you're going to be able to continue on with it. It's the idea of limits that I want you to really hang on to. It's a very big idea in the very beginning of calculus when we start talking about functions and what we're looking at. So we want to know if a function is continuous if there are no breaks, there are no holes, there are no gaps. It's like if you're running your finger across it or your pencil across it, you don't have to pick up your pencil to continue on with the function. It's continuous. And then the other definition is a limit. So the limit, when we talk about it in this class, is as you're approaching an x value on the graph, if you're approaching it from the left or if you're approaching it from the right, say the function is like this. Actually, we can just look at this function here. If I'm approaching this number here, then I'm going to say the limit is 2. Here's 2. You know, if I'm approaching it from the left side, if I'm approaching it from negative infinity, if I'm approaching 2 from the left side, it is continuous, right? I'm coming up to it, and as I'm just getting ever so close, reaching it, approaching it without really reaching it, that's what the definition says. I'm just about at 3, right? I'm just about at an output of 3. And if I'm approaching it from the right side, I'm coming down on it along the line, I'm just about there, and you know, it's almost 3 there as well. So that's a limit. And now we're going to talk about types of discontinuity, because sometimes there are going to be breaks in your functions, right? Parts of your function may be continuous. You know, if you're looking at a specific point of your function, it may be continuous. It may satisfy both of the requirements to make it continuous. But then, let's look at this right here. There's infinite discontinuity, right? We've seen some vertical asymptotes before. It never quite reaches that point there, and I'm going to say it's about positive 2 on the x-axis. It never quite reaches that 2. Right, so there must be something in the way of making it get to that point, right? So there's some discontinuity. There's an asymptote there. There's what is called jump discontinuity, which is the function comes up here and then all of a sudden, boop, jumps right up here and moves on, and that's a piecemeal. We've seen piecewise functions. And we've talked about it. This is a sort of a piecewise function right here that we'll talk about later. And last but certainly not least, there's a removable function. And the removable function says that there's just one point that's been taken out of it. It doesn't work for one single point. But you could, if you filled it in, have a complete continuous function. And there's a removable function that has, you know, maybe that point at that particular spot, you just pop up here, boop, and then you get right back into that function. That does exist, so that's a removable type of discontinuity. Right? And those are the 3 types, and we'll talk about it more in class, and you'll look at it on your study sheets, and we'll get maybe more in depth as time goes by. And now there's a continuity test, and that continuity test is very simple. There are 2 things you have to do. We have to satisfy the fact that we plug in the value that we're finding the continuity for, right? We plug it in. Function of x is x cubed, so we say, well, is it continuous at 0? Okay, well, we take that 0, we plug it in, we say it's a function of 0, we put 0 in here, we cube it, we get 0. Yes, it's continuous because that's a real number. It exists. Then we say, okay, well, here's limit notation. If we have a limit as x is approaching 0, does this work? And we basically do the same thing with limits. We take the 0, we plug it in for x, and we see if it works. And yes, it is real, and so it does exist. But what if we have that piecewise function? What if we have this piecewise function, and we're going to do the same thing? So we say it's a function of 0. What we're going to do is we're going to plug in our 0 for x, and this does not exist. And we're going to plug it in for both parts of our piecewise function to see if it's continuous at 0. And as a matter of fact, it does not exist at 0. And so this is not a continuous function because it has to satisfy both requirements to be a continuous function. So this particular one is not continuous because 1 over 0 does not exist. We'll do more of this. If you have any questions, always remember you can send me messages.